Today's lesson is 4B.3, Similarity, Proportionality Theorems. We have three proportionality theorems for similarity, and we're going to go ahead and start with the triangle proportionality theorem. This theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionality. The converse of this is also true. In our figure below, triangle AEB has this line right here. This line CD is parallel to line AB because they will not touch each other even if I extend them. It should be marked in the picture below. And when it does that, it's going to take this side here, AE, and it's going to split it proportionally to this side BE. It's going to split right here so that I can compare this part to this part, this to this. All right, let's go ahead and take a look at our two examples on how we can do that. So notice that I do have the parallel right here. And so what this theorem says is that I can take my two sides and I can make this into a fraction and I can make that side into a fraction. And it's almost like they're set up for me. I can go ahead and on the pink ones, I can go ahead and say 33 over x is equal to, and now I can go to the blue side and I just put it in the same order. 27 because it was on top of, it was first just like the 33, and then 18 on the bottom. Now I can go ahead and I can just cross multiply. So remember we're doing x times 27. And we're going to do 33 times 18. That's 594. To solve for x, we would simply divide by 27. And earlier in my calculator, I got 22 for my answer. And that's it. Let's take a look at the second one. Notice they're asking me to just find x as well. I can see my two parallel sides. If I use the same idea as before, I'm going to take this and I'm going to take this side and I'm going to split them. Now, if you notice that the blue side is already split, so I'm going to do the blue side first because the blue side is already 12 and 4, or I could put it the other way. I could have put 4 on the top, it doesn't matter. For the pink side though, I would put x because it is in the same place as 12, but for the 4, I would need this spot right here. I'm going to squiggle it in. Well, the whole thing from the end right here to this end right here, I know is 20. So what would I call that squiggly pink part? Well, I would call it 20 minus the x that's above it. Little bit tricky there. Now that I've gone ahead and done that, I'm going to go ahead and I'm going to cross multiply. When I cross multiply here, remember I have to multiply the 12 times the 20x, so I must have the parentheses. And here I'm just going to do x times 4 or 4x. I have to distribute the 12 inside, so 12 times 20 is 240 minus, because that's what I see inside the parentheses, 12 times x is 12. I have two x's. I'm going to go ahead and just put them in pink. I have to get them together on the same side. Remember, this is where my line through my equal sign comes in handy. I'm going to go ahead and even though 12 seems to be a bigger number, I'm going to go ahead and move it over with the 4 because the 4 is by itself. That's the reason I'm choosing it. Plus 12 is actually smaller because it is negative. That would give me 16x when I add them together. Now all I have to do is divide by 16. Oops, there we go, that looks better. And I get 15 is equal to x. Now that was a little bit tricky. And some of you might be looking at the picture and saying, Miss, there has to be a better way, an easier way. Let me go ahead and change my color and let me show you this. I can use this proportionality theorem to also set up this equation. So I'm going to go ahead and keep the 12, but this time I'm going to get rid of the 4. This time what I'm going to use for the pink is I'm going to use the X and I'm going to use the 20. Now keep in mind where the 20 is. So let me show you where the 20 is. I need that same thing over here on the blue side. So what I'm going to do to get that is I'm going to go ahead and I'm going to add 4 plus 12, 16. So instead of using the 4, I'm going to use 16. Watch what happens when I cross multiply. X times 16 is 16x. 12 times 20 is 240. 240 divided by 16, just like it was in the last problem, is 15. Either one of these will work, and the proportionality theorem allows me to do either one. Okay, let me change that back to my black pen, and let's go ahead and look at our next proportionality theorem, which is my parallel lines and transversals. It says if 3 parallel lines, 1, 2, 3, intersect 2 transversals, 1, 2, then they divide the transversals proportionally. What that means is I can make a fraction with these, and I can make a fraction with those, and I can set them equal to each other and cross multiply just like we did. Let's take a look at our first problem. So I'm going to take these two right here, and I'm going to take those two right there. I'm going to go ahead and make my two proportions. Now you could make them. You could do pink over pink, blue over blue, just like we did, or I also want to show you that you can do this. Notice I took the pink and I just put it as my two numerators, the tops of both of my fractions, and then in the same order. Order matters tremendously when you're doing proportions. You always want to make sure you do the second proportion the same way you did the first one. So I put 12 first because I put X first. And now I have my proportions set up. I'm going to go ahead and cross multiply. So X times 15 is 15X. And 12 times 12.5 is 150. I'm simply going to divide both sides by 15. X equals 10. Okay. All right, let's take a look at our other one. This one, I'm going to go ahead and do pink over pink and blue over blue because I'm looking for fractions. I'm looking for them to look like a fraction to me. So notice this looks like a fraction with the bar in between, numerator, denominator. This looks like a fraction with the bar in between, numerator, denominator. Over here, I made my fractions this way. It's fine as long as I do it correctly, as long as I do them both the same way. So I'm going to go 27 over 18, and I'm going to do x plus 10 over x. I'm going to go ahead and cross multiply. No, it doesn't matter which one you do first. I've gone back and forth between the two. Remember that when you do the second one, though, you are distributing it to both the 18 to both the x and to the 10. So I've got 27x, 18x, and plus 180. I have an x on both sides. I need to be careful though and mind my equal sign. I cannot add them together. I actually need to take the smaller one and move it over with the larger one. Or I need to take the one that's alone and bring the other one to it. That would give me 9x when I subtract, and now I can simply divide both sides by 9. And yep, x equals 20. There we go. Our last proportionality theorem is our triangle angle bisector theorem. This says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. What you're going to notice is that you have a triangle, that one of the angles has a line coming through. this ray is going to bisect it so that these two angles right here are the same length. Then I can make this side of my triangle into a fraction, numerator, denominator, and then I can take this side and do the same thing, numerator, denominator. Here we go. So once again, this is a little tricky. So it's going to be this one and this one go together, that one and that one go together. Notice that I'm not putting really together, or I'm splitting right here at the bisected angle. So there they are. There's my two proportions. There are my two fractions, my two ratios. So my pink one would look like x over 8, and my blue side would look like 12.5 over 10. And now we're going to go ahead and we're just going to cross multiply. 8 times 12.5 is 100, and then I just divide both sides by 10. That's a pretty easy proportion to solve. X equals 10. Perfect. Let's try this last one. So if you go ahead and take a look at the last one, notice that you're going to put those two together as your fraction, and then you're going to put these two together as your fraction. Maybe just to walk a little bit on the wild side for this last one, I'm going to go ahead and take the pink and put it as x over 10. That's perfectly fine. If I do this, though, I must change it to 15 over 20 because they have to have the same order. When I cross multiply, I have to oop, that didn't work. There we go. I have to cross multiply 10 times 20 times x, 20x, and 10 times 15, 150. I'm going to divide both sides by 20, and I get x. I can do better than that, y'all. There we go. Equals 7.5. Good luck on your assignment.